Good morning. I'm Dr. Sanjay Jain, Associate Professor in Mathematics at SPC Government College, Ajmer. Today, we are taking lecture on continuum mechanics. Earlier, we have studied some product like dot product, like cross product in our earlier lecture, or two type of tensors like conical ij and hexagonal ijk. Today we are going ahead from that. After studying dot and cross product, we are taking two type of multiplication here of Cartesian tensor. The scalar and vector product of two vectors are very special cases of multiplication of Cartesian tensor. In general, multiplication of Cartesian tensor can be classified into two types. These two types are outer product and inner product. Okay, what is the meaning of outer product? An outer product of two Cartesian tensor is a Cartesian tensor obtained by placing the two original tensors side by side with no summation indices involving the suffixes from both tensor. This is an important involving the suffixes from both tensor. An example of this outer product of two second order tensor, that is Aij and Bij, the resultant of these tensor as outer product, it may written as Aij BRS, and it becomes tensor of fourth order, two of Aij and two of BRS. So this is an outer product where order of tensor increases. Okay, this is called outer product. They are taken side by side and increases in the order. But in case of inner product, first define contraction, which I think you have studied in your previous tensor analysis or tensor algebra paper. Contraction as the product of identifying any two indices of a tensor. An inner product of any two tensor as an outer product, like outer product, follows by a contraction. Outer product that follows by a contraction, meaning the same indices have contracted, and due to this contraction the order of tensor become less than the original outer product tensor. Okay, this is the main difference between outer product and inner product. Here total order is less than their original order. As an example, if we have a product of two tensor AI and Bij as an outer product AI Bij, or it may AI Bji. Okay, what we are seeing here, I is the same indices in both. Okay, so we can take contraction on I. So after I, there are total tensor, Cartesian tensor becomes less order. Here, one in earlier cases, we are seeing it should be observed that dot product and cross product introduced earlier are special cases of inner product of Cartesian tensor. How it is, you had taken in our earlier lecture, AIK, AKJ is nothing but conical ij. How many? As outer product they have a four order tensor, but after contraction it becomes two order tensor. K and K, that is red line indices, become contraction and remove. So we get conical ij. This is less to order than outer product. So this is an inner product. So these are two type of product: outer product, inner product. After studying dot product and cross product, these two type of Cartesian tensor product also exist, which we studied later on. Also uses also in some application of Cartesian tensor. Okay. Next, in next slide, we are taking a very important identity that is called Epsilon-Dale identity. What is the meaning of Epsilon-Dale identity? It is nothing but it is a relation between epsilon, that is permutation Cartesian tensor, and conical is Cartesian tensor, conical Cartesian tensor. So Epsilon-Dale identity is nothing but a relation between epsilon and delta. Any kind of relation between epsilon and delta can be also deduced from Epsilon-Dale identity. Here we are taking some cases. This is an Epsilon-Dale identity written in that form. Product of two epsilon symbol Cartesian tensor, epsilon PQS, epsilon M and R. These are two epsilon symbol having all different indices PQS, M and R. This may be represented as indeterminate form of conical like that. Conical MP, that is first indices of the both epsilon sign. Okay. Conical MQ. M is the first indices of second conic epsilon and Q is second position. So similarly, third position. Okay. 2 1 position, 2 position, 2 3 position, 3 1 3 2 3 3 position of MNR and PQS are taking in form of conical. So this is a simple representation of product of two epsilon symbol in form of conical deltas of determinate form. Okay, when we open this conical deltas, first part epsilon PQS, epsilon SNR. This is an important PQS epsilon SNR means what we are observing from above part to that part. One indices of S is common. Okay, so this may represent by these quantities, removing S from there and other permutation or combination of conicals are there. Okay, if we taking in second part, we are taking two indices are same Q and S, then its value is minus 2 del PR. Okay, these are the sub part of the Epsilon-Dale identities. Okay, we are how to we establish this identity. Here we have already seen in our earlier lecture this one, that a determinate A or determinate Aij, small aij, can be represented as epsilon ijk, a1i, a2j, a3k. This we have seen in our earlier lecture or yesterday lecture. Now using this, first we have taken that any determinate A is nothing but determinate Aij. Okay, here we take in place of a small aij, we have taken capital Aij. So it may represent like this: A11, A12, A13, A21, A22, A23, A31, A32, A33. That is determinate A mathematically represent. And by using the property of determinate, if we change row or column, then we observe that one sign, if we change one row, we get one negative sign with determinate A. Similarly, if we change one column, we have one negative sign. Okay, so in that case, if we change one row, Here you have observed A11, A12, A13, A21, A22, A23 are interchange in row. But in that case, what we are seeing, column is change. A11 is going to place of A12, A21 is in place of A22, and A31 in place of A322. So two columns are changes or two rows are changes. First and second rows are interchanged, first and second columns are interchanged. Then we have one negative sign due to one changes of rows or column, we get minus determinant A. Okay, this is the simplest way and we know that rule. Okay, but what we are doing here, we are taking here arbitrary number of row changes in the first part, means M and R. First row, second row, third row changing by M and R time. So it nothing but it's a minus sign, can be either even permutation or odd permutation. Okay, so we can write in place of minus sign because we are taking arbitrary time. So it is epsilon M and R determinate A. Okay, in case if it is an even permutation, then this becomes positive, or in case it is odd permutation, it is minus. So 1, 3, 5, 7 changes continuous in row, we have a negative sign. But in case of 2, 4, 6 changes positive, even permutation becomes, so it is a positive. Okay, the same thing we are also using arbitrary number of changes in column. In that case, the second identities are PQR. So it becomes PQS determinate Aij. Okay, when we change number of rows, R is there, that's why we are taking here PQS, not taking R. So number of changes MNR, then we get epsilon MNR determinate A. Or in case we change PQS changes in column, then we get epsilon PQS determinate AIJ. If here we have taken arbitrary number of changes simultaneously in row and column. Earlier we are seeing that arbitrary number of changes either in row or in column. Now in the last phase we are taking arbitrary number change simultaneously in row and column. That means M, N, R or PQS. So it becomes epsilon PQS, epsilon MNR, and determinate AIJ. Product of these two cases or after changing arbitrary number of changes simultaneously in row and column. So we get two type of epsilon symbols. Okay. Now after that, writing this, one more thing we are doing here, we are taking Aij replaced by conical ij, and when we take in the determinate Aij or conical ij, we have to know what is conical ij. When I and j becomes equal, it taking value 1, and ij are not equal, it becomes 0. So it becomes diagonal matrix of 1, 1, 1. So its values is 1. So when we substitute Aij by conical ij, so determinate Aij becomes 1. Using this symbol in our epsilon last here, this determinate Aij become 1 and AMP become conical MP, AMQ become conical MQ, and AMS become conical MS. Similarly, these all changes with conical symbol because we write Aij is equal to conical Ij. So we get this identity. This is a first form of epsilon del identity in which all indices are changed. PQR, MN, PQS and MNR may be written as this. Now, after doing this, for the second indices, what we are doing? Taking M is equals to S in this part which we have get. When we substitute M equals to S, we get this inequality changed to in this form and open this indices in form of in using the determinate notations. So after opening this, we get epsilon PQS, epsilon SNR is nothing but conical PN, conical QR minus conical PR, conical QN. This is when one indices M is equal to taking S, or in terms of outer and inner product, we may say contraction exists for M and S. So it is in a second form of conical Dale, or exactly this is an epsilon Dale identity in which one indices are same in two permutation symbol. Okay, second form is an exactly epsilon Dale identity. Okay, what we are doing here, one contraction we have already seen in M and S. Now we using one more contraction in N and Q. So after taking N equals to Q, we have taken two contraction, or two indices are equal. So we get epsilon PQS, epsilon SQR. So here S and Q are same, P and R are different. So it becomes minus 2 del PR by using conical II is equal to 3 and conical IJ equals to either 1 or 0 dependent upon the indices. So we get this is in a third form of conic epsilon Dale identity in which two contraction exist, and this is nothing but minus 2 Dale PR. One more thing I want to establish here, if we apply the third indices also for contraction, then our this sign becomes minus 2 del P equals to R. So we get minus 2 del PP, and del II is 3. Therefore, del PP is also 3. So it becomes, if all three identities are same, that is epsilon ijk into epsilon ijk is nothing but minus 2 into 3, that is minus 6. When all three identities are contract. So this is an epsilon Dale identity, all three form, and one more form in which we get numerical value. So this is a very important question of epsilon Dale identity, which is in all time, in all way, in many form, may be asked in exam. Always try to ask in some other or other form way. So one most question also coming in all exams related to continuum mechanics of epsilon Dale identity. That is a very important question. Okay, so for today we are ending here. Thanks. Okay.